All right, looks like we're live. Okay, fellas, I'm going to go ahead and go to the whiteboard here, and we'll start right back where we left off last week. Right. I know we had some struggles last time, but I reset my computer and it looks like we're back up and running. Okay, last time we just were going over troubleshooting with electrical. And you go, let me know if something's gone haywire because I can't see my screen from here. And we were just made a simple circuit. Remember our 208 circuit here? Basically a control circuit. Virtually all our control circuits look like that. Of course, we have the protocols and the super pluses that are 120 volts, but it does the same thing. This line here will just be a neutral. It just won't be 208. And they're much easier to troubleshoot, in my opinion, because you can literally check stuff to ground. I mean, you could just hit your ground bar and start checking until you find your open circuit. They're much easier. But for the most part, we are using the 208 volt circuits. So we'll just stick with that. I think what we were going to do last time is go over an oil fail, because I get a lot of questions on oil fails, and not what causes them. We won't go over that, but kind of like what's the control doing? How is it working? Here's our contactor coil. And what's it doing inside there? So what I'm going to do is I'm going to draw the old school ones, and then we can easily adapt it to the electronics and tronics because they're virtually the same thing, but just not as cool. So we're going to call that our low pressure, high pressure. Let's connect our high pressure so it's working. And then we're going to go to our oil fail, which our oil fail has an L. Remember L for line, M. Let's put L over here. L and M for machine. If you can remember that, that's going to really get you by. And inside here is a switch. It is oddly enough, it's a temperature switch. So we're going to draw that like this. And you say, well, temperature switch, how's that even possible? They use a temperature switch in these older ones. This is the pen, you know, the gray pens that we're so used to seeing, just has a little reset button on it. But it's a temperature switch. And what's inside that temperature switch there, and the magic that makes it work, is it has a, let's see how I can draw this. M, we're going to go to, what is it? Is it T1? Yeah, T1 and L2, right? M jumpers to T1. You guys are going to have to help me out on this one. Put L2 down here. Or T2. T2 just goes back over here. And it goes through the word contactor. I'm going to erase that so it doesn't confuse anybody. And goes right over there. So let's put our jumper, and then M connects to our coil. So when everything is working good, we get our 208, 15 amp, 208 volt circuit, goes down this way, comes through the controls, hits the L, the control is closed, hits the M, compressor contactor comes on. Normal operation, right? On this diagram, if the low pressure opens or the high pressure opens, it kills the circuit. Contactor turns off. Of course, we can put a relay output in here. So let's just do that for our, because that's what we work on a lot. Relay output, RO. So that's controlling your compressor. And that's it. That's how it works. But the cool thing about this here is what's going on inside this control. And I'm not sure which side it works here, but I'm going to draw it like this. So internally, out of T1, it goes over to a heater element. Just draw that little wiggly lines. There's a heater element there. And out of that heater element, it goes to a pressure control. Then out of that pressure control, it goes over like that. So let's just say it calls for the compressor to run. The electricity comes through here, hits L, and it starts the compressor contactor like normal. And then the compressor runs, it starts to run. And what does that do here? It now, inside this pressure terminal here, which is basically the two pressure terminals that you have on there, it's a differential pressure. So you're going to have one pushing back, one pushing up. So let's draw the one pushing up. They're fighting each other. So if the pressure, you get a pen that's not dried out. If the pressure, let's just say this is the sump and the oil pressure. If the oil pressure is higher than the sump pressure, it's going to go ahead and it's going to open this circuit, not allowing it to flow through the heater. That heater is calibrated to give whatever amount of seconds that the pressure control or the oil control is rated for. Let's just say it's a 90-second or a 60-second, whatever they are. I think they're 30, whatever the two are. I can't remember offhand. It doesn't really matter. But it's calibrated. Let's just call it 30 seconds. If it keeps getting power for 30 seconds, it's going to be enough heat to take the temperature and push it open like a click-on. It's going to push it open, killing power to the compressor. That's what I'm going to say. Well, you know, if you pulled one of the grate covers off and you got that white resistor on there and you could feel it's getting hot, that's not the heater. That resistor, I could draw it out bigger, but that resistor is for when it's 208 volt. It puts the resistor in parallel with the heater in order to keep it the same. So when you put 120 on, it actually bypasses the resistor and goes straight to the heater. So it's calibrated. That heater is calibrated at 120 volt, and then the resistor is the exact same resistance as the heater, which will then keep the calibration the same with the 2 volt. Any questions on that? You follow me? Just so I guess kind of forget about what I said about the little resistor. The little resistor, you feel your thumb on there, you can pull the cover off, and if that thing's hot, if it's getting warm, you've got your oil pressure is not high enough. You could tell if your oil pressure is not high enough by your thumb on that little. It looks like it's just like a rectangle thing that's got a weird shape in the middle like that. It's a white resistor that's right on the outside of it. And that just keeps the resistance doubled up so that you could use 208 volt or 120. You notice that they've got a 120 or a T2, right? You could use either. I mean, we could even put it down here. We could put the resistor here. And then I don't know if this is the order it's in, and then come out of here to 120. Or this is 240. So it would work like that, but internally, I don't know if it's wired like that, but it would work like that. The 120 would give you the exact calibration you need, and then the 240 going through the resistor would also give you the exact calibration you need. So let's just say it goes ahead, it starts to run, the heater starts heating up, the compressor starts running, the oil pressure gets high enough over the sump pressure that it pushes this circuit open. Now no more currents running through this circuit, and it's not going to trip. That's how they work. They're cool little devices. The guys back in the day, man, they knew what they were doing. They really did. Nowadays, you got the Centronics that literally gets rid of all this stuff and just makes it a switch here. Just a switch like a relay output. It's got the electronics that does all this old school stuff. But it's that easy. It's not, there's nothing more, scientific about it. It's using Ohm's law, it's using pressure, and it uses the heater as a time delay. That's the time delay right there. You would think right off the bat, like, oh, it's using the oil pressure as the switch, but it's not. The oil pressure is the switch to kill the heater so it doesn't heat the click-on up high enough to open the circuit. And I don't know if I'm, maybe you guys don't see them anymore. I know that they're almost gone, but you're gonna come across them. This is the old ones, the gray ones, the pen. I can't remember the name anymore. That's the numbers. It's the pen oil fill controls. You got one for Copeland and one for Carlisle, and that's how they work. Any questions about that? I guess one question would be, how would you troubleshoot it? Also, this is wired 3-wire, okay? Guys, it's this simple. 4-wire is nothing more than this jumper removed. And now remember, you need power from this side to make it work. So let's go up this way. It jumpers over that, and it goes over past the RO over to here with a side switch or something, a CT, some other device. So when the compressor starts to run, it closes the switch, sends power down like this. So a 4-wire is actually more complicated, but easier to wire. I guess there's more stuff going on. So that's why on a 4-wire, you always will see a CT to know that the compressor is running. The good thing about that is it will not ever trip if the compressor is not running. So it won't. It does away with a lot of oil fail like nuisance calls. If the compressor, let's say the compressor breaker is tripped and the compressor's not running, even though the contactor's pulled in, it's never going to give the power over here to run the heater to trip it on oil fail. So keep that in mind when you're troubleshooting these things. Is it wired 3-wire? Is it wired 4-wire? There's got to be questions on that. That's kind of a thing. But I think 3-wire is more neat and simple, so we'll stick with that for now. So remember, a 4-wire connection just means it's got 4 wires to it. 1, 2, 3, 4. 3 wires means you have the jumper right here between M and I think it's T1. Whatever M jumpers to, that's this. I think it's T1 or whatever it is. Whatever it jumpers to. It's the one right next to it, right next to M. Why do we jumper M? I get that question sometimes. Let's go back to on a 3-wire. Why do we jumper M? A good question. Glad you asked. Why don't you jumper L? Well, you could jumper L. Wouldn't be a problem. Unless this trips. So the reason we jumper M is so that if this does trip, opens this circuit, it kills power to the heater. You don't want this to keep heating up. You want to be able to reset it. If it's got power all the time, let's just say for some reason these wires were crossed up or something, which you could find. If you find one of these things that's on all the time, and you try to reset it, but the little resistor is hot, it won't reset, the problem is going to be the M and L are crossed. A little troubleshooting guide. And so imagine if you had L over there at T1 and it tripped. Yeah, it's going to shut off the contactor, but it's still going to power up this heater circuit and also this resistor. And because it's not going to have oil pressure, so it's going to constantly have this feed here. And so you go to reset it, and it won't reset. If you ever come across one that, you're like, L and M is open, but it won't reset, and it's an old school one, put your thumb on that little resistor. If it's hot, it's because it's crossed right there. So you go ahead and you uncross it. Now you got your jumper back there. and your circuit is like that. This is no different than any of the other ones. Always check it between L and M. If you've got 208 volt there, the switch is open. Most of the time you're come up to a compressor, it's off. You're going to try to figure it out. You're going to put your leads here. Well, you're going to check your breaker. Always check the simple stuff. Start with the simple stuff. Check your control power. Do you have 208? Yes or no? No? Go that way. Find it that way. Something's wrong that way. Yes? Something's wrong this way. Okay? First things first, check your power. Yes, I've got power. All right. Do I got power to buy across my RO? Nope. Low pressure? Nope. High pressure? Nope. L and M? Yep. That's your open circuit. All right, let's do another one. RO? Nope. Low pressure? Nope. High pressure? Nope. L and M? Nope. What the hell? I got power there. It's not pulling in. I got a bad contactor. Okay. If you got no power here either across that, now you've got something weird going on, and now you got to work your way back in. You'll check here to here. Do I have 208 here? Yes. All right. So there's something going on in here somewhere, but you don't know where. Or, most of the time it's going to be a wire nut popped off or whatever. But then you would check like this. You would check over here, and you would go like this. Boom, 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 boom. You'd find it in there. But you can't use ground. Because, again, you check the ground, you're going to have power on everywhere. It's going to always have power. You got power there. You got power there. The whole thing's going to be powered up. It's going to be power. So you can't use ground unless you're trying to figure out if you've got like power to the circuit. So that makes sense. So the way you go about the troubleshooting this stuff, and this is about as complex as they get. That literally, you could just let's just say you've got an older system and it's wired like this. Copy paste, copy paste, copy paste. It's all the same, all the way down. It's all on the same breaker. It just continues down. Add a toggle switch here and a toggle switch and a toggle switch. Well, it'll be one toggle switch, but you get the picture. One side of the toggle switch here and the other side's here. And you can continue this down the line. It's that simple. There's nothing more to it. I don't know what else there could be in there. Maybe on a Carlisle, you'll have sometimes, like on those 06Ds, you'll have a thermal overload that it'll go through. But that's fine. You put that in the circuit. Here's your thermal overload. It's there. Just remember that your oil control should always be last. There is some exceptions when you come to demand cooling, especially retrofitted in. We could go over that. If we go over that, maybe we'll save that for the next one, because there's a couple of ways to do demand cooling. Because the reason is because you don't want that solenoid. Let's just say if it trips on oil fail, you don't want the solenoid to be energized. So let's just say I put demand cooling over here, and it's hot enough. Obviously, compressor's not pulling in. It's probably not going to be hot enough for the solenoid to come on. But let's just say it's a super hot day. There is a chance that the solenoid could come on the way it's wired, before this. So the demand cooling, you're going to see a lot of times on this side of the circuit, and it'll also be tied in to the L. So I got to look at I actually going to have to look at the wiring diagram, and I'll do that next time. But you have to bring there's a separate wire you have to bring around in order to make it work. And I'm not prepared for that. I should have probably prepared a little bit better for that. But that's either here nor there. We'll go over it next time. I'll double check and I'll look on the wiring diagram. There's like 4 different ways to wire demand cooling. 4-wire, 3-wire. It depends if this is a 3-wire, if this is a 4-wire. There's all these different scenarios. If the demand cooling is wired as a 4-wire, you could put it over here, no problem. Because if it trips on oil, you're gonna open up the current sensing relay, and it's not going to power up the solenoid. So I'll get into that when I got a bit better, that I can look at all the drawings in front of me, because I don't want to mix up some wiring here and then confuse you. So on the same circuit, this is what you call the ladder schematic, and you keep bringing it down. You add whatever you want in here. Like we went over it last time. We add a RO and a solenoid valve. Another RO and a solenoid valve. Toggle switch, toggle switch, toggle switch, toggle switch, RO, solenoid. And that's all. It's super simple circuits that we're working on, fellas. It's nothing. That's all there is to it. Yeah, there's going to be some stuff where there's some dual temp stuff, but that's going to be nothing more than at the rack, you're going to have a different RO that's going to give it another dual temp, or a toggle switch. It's going to be like, let's just call it a toggle switch here for dual temp. A bypass solenoid. Actually, it'll come from here. My bad. Come from here. Dual temp. But it just adds. You just add it in there. You could just build this stuff. And if you think like something catches fire, you guys can rewire this. I know. I got faith in you guys. It's easy. Because it's just that simple. Draw it out. You know how many times I've had to come in and put in an EMS system into this, but I've drawn it out. I've seen what I got. All right, draw it out. Okay, and I look at it and say, okay, I need to put this here, here, and I go to work and I just put it in. I put in a billion ROs into systems that had gang clocks on it. So, and that's all I did. It's literally that simple. Sometimes, let's just say this is down at a case and it doesn't control temperature, but it's got a T-stat. Well, that'd be here, down by the case. But it just goes in the circuit. Just literally goes in like that. So you can just add stuff wherever you need it. But you also, knowing this, now you know that if the solenoid in the case isn't working, but the RO is on, there's something down there. Something keeping it on, or an open circuit somewhere. But if you've got power on and you check for power here, check for power here, check for power across your RO, you're good. And then it goes out like this. This is where it goes out of the box and goes down to the case. Maybe there's something down at a service meat case or something. It's probably a T-stat. But you can know what you're looking at. You go in the motor room and you're like, I got power going out to it, because you can see the circuit. You can check it at the terminal strips or wherever. Just pull on wires. Look at it. Look on wiring diagrams. A lot of your wiring diagrams on the newer cases are going to show you which terminals are which, and they'll be labeled, you know, wherever it goes out to a case. Let's just say this is system A1. It'll just say, you know, A1 B or whatever, A1 C, but it'll be labeled little terminals here where the electrician's going to come in and he's going to pull his wires in from the case and he's going to land them on these terminals up in the rack. If it shows a terminal A1B and A1C and the electrician's come and pulled his wire into it, you could check right there. You've got power going out into the store. Well, you know your problem's not in here anymore. Go look for it. It's in the case. It's all on the wiring diagrams. These wiring diagrams, they could be on most of the time on the rack. What you're going to find, these are almost always custom made. Let's just say this is out of the case. You're going to see right here will be a dotted line. That dotted line means field installed. How do I know that? Because every time you look at the corner of the wiring diagram, it's going to show dotted line. It's going to say field installed. Remember, on all wiring diagrams, there's going to be a menu over here that tells you what everything means over here. So if you look at something like this and it says, oh, field installed is a dotted line. Oh, right here, dotted line, field installed, meaning an electrician or somebody, doesn't matter who, came and this is not part of the rack. These dotted lines were not part of the rack. But it's part of the system. And it's all engineered to be there. So keep that in mind and keep eyes open for that. Right, what else are we going to talk about? It's already 7:20. Oh boy. Going quick. But yeah, I wish I would have prepared a little bit better for this. Because I thought that there would be some more questions on the oil fail, but it sounds like this is the last time anybody's ever going to call me on oil fail. So that's great. I love that. Because everybody gets it. Anybody struggling on any store heating? I know that right now, guys, at the time, I'm going to take a break from this for a second. I'm going to come back to this, and we're going to add in a demand cooling. So I think that's really all we have left, and the compressor circuit is complete. We've gone through it. So I will erase this next week with a diagram in hand. I'm going to print it out because it's like 3 pages. There's literally 3 pages of wiring diagrams that you're going to come across, and we'll go through all of them. So I'm going to pause this a little bit here. I want to talk a little bit about store heat because the stores, it's not going to be long, and you probably already have been hearing it from managers how cold it is. We got to get these things working. We have to check all of our stores right now and make sure the heat's working and verify that the heat exchangers are all, the auxiliary heaters are working. Because if we don't, it's going to take too long for us to get those replaced. And by that time, they're going to be crying bad. And I don't blame them. Some of the stores will get down into the 50s. So is there any questions on store heat? Are any of you guys having trouble with the store heat? Like the heater's working, but it doesn't seem to be making it down to the sales floor?
I have one store where the The high limit switch keeps tripping, but every so often.
Yeah.
I just pop in and reset it, and then it's back online.
You guys know that some of our stores that, especially the older ones that were made right, and they're starting to do it now on newer ones, is that we have under case return errors, right? And how in the winter time it's not nearly as important as it is in summertime. It's not nearly as important as the winter time, but it's crucial that we know how those things work in the winter time, and to look for them and identify any problems that, maybe a damper needs to be moved to get more air out through the under case returns. But first of all, make sure that your store is the furnaces are working. Now's the time. So this is a struggle on a lot of stores that we have a return air up in the ceiling, because all the cold stuff is down here at the sales floor. And I swear there's times that you're gonna have it, 62 degrees here and 101 degrees up here. If you're running into that, let us know, because I think they're going to allow us to start putting in destratification fans in. I know what really does, believe it or not, what helps a lot is, I know a lot of you guys do this. I know that there are some people that don't like to see this, but I'm not one of those people. We have, by the way, this is a side view looking at the cases. That's a case looking at the side. This is a store. And this is a back-to-back lineup looking at the side of it without the crown end. You guys are putting those fans in right here, the blue blowers, carpet blowers. To keep it, the air moving through here. Those actually help. Because if it's warm up here, it's taking the warm air and it's kind of dragging it down, and it's bringing it down and out here. So those help. They kind of work like a destratification fan in a sense. But yeah, the destratification fans are the air pair ones.
Those like the Aldi's ones?
Yes. That shoot that stream of air down. Can you imagine the amount of electricity and heat and gas that we're wasting to keep it hot up here, and the customers aren't happy? But if we can keep the store, nicely heated throughout, we won't have this. It won't have to be 101 degrees up here. However, we have these things called undercase returns, where the return air comes from under the case. Keep this in mind if you've got a store. If you've got somebody's come in and done a remodel and you've got undercase returns and they've blocked the entire toe kicks with brand new toe kicks with no slots in them, let us know. We need these toe kicks have to be slotted so that the air that's 60 degrees here can go through and down and up into the air handler. And why would we want to do that? Well, because something has to replace that air. Guess what that is? It's the 101 degree air. It's forced to come down because why is it up high to begin with? Hot air rises, gravity, right? It's expanded. The more compressed molecules are going to sink. But if we can yank them out, our 1 degree air is going to come down, and it's going to blast everybody with some nice, warm, nice heat dissipating, heat energizing air. So what I was getting at is that make sure that the toe kicks aren't solid. Now, the Husband ones, they have a pretty good gap. So those usually work okay. If you look at the Husband cases and you look up, there's a pretty good sized gap in those. Those work. But what the ones that don't work is like the old Tylers or the old Hills. That's just a piece of metal. It's almost always in the back wall because it's easiest to, it's easier to get this back up and out if it's at the back wall. So this would be like the meat cases or dairy cases, back in the back wall. If you've got a particularly bad store, like we had at an Albertsons, small store, no undercase returns. It was on Coronado Island. It was a disaster. I mean, if you're at your wit's end, air handler's working, everybody's screaming, the store's warm, tears are coming, nobody can fix it. There is a way that you could go out to your frozen food cases, put an adapter here all the way across the case, and put a return air. It looks like a false column. Like that. Seal off the top of the cases. Now all of a sudden you've got a false column that's moving a bunch of air up. And it's actually turned this backwards. Now, this also works in the summertime because it's going to take all of the air is going to go this way and it's going to clear up all the sweating cases. It's going to work year round. So, think outside of the box. That works too. This is the best way along with this because it costs no extra money. The air pairs, they work, but you've got to pay the electricity to share down. But if you're going to run that fan anyhow for the heater, might as well just, yank the air off of the sales floor somehow, some way. So think outside the box. Let's try to get the heat down. I don't know if you guys have ever done that, but you got to stand on top of the frozen cases and you have your hand way up high on the temperature. And it's literally 100 degrees, but it's 60 degrees on the sales floor. That's one easy way to do it. And it's just one duct, run it back to the return air, plug it in. Everybody's going to be happy. And then you don't need blowers either, blowing down. So, yeah, now's the time to start looking into this, guys. It hasn't been real bad with the calls. Call loads have been pretty low. But let's get the store's heating working. If we don't do it now, and we do have a heat exchanger that's rusted out, cracked, or whatever, we're not going to be able to get a new one in until probably January. So, and that's if we're rushing it. We can't just have them on hand because there's so many different BTUs and stuff. So having a pack of those doesn't make any sense either. What makes sense is to right now look into it, get them in. We can, get a new heat exchanger if we need it, have it in a couple weeks, 3 weeks. But come January, man, or even, usually by now, it's been an awful warm October and November. Usually by now, I've had nothing but, it's cold in here. We've all heard it. right, let me take a break, use the restroom. And I think our time is up for today. Shape up. See if we got any action going here on YouTube. I don't think I made it public. I should, so we can come back and look at the comments. See everybody saying, well, you know, the math doesn't add up. All right, any questions? Looks like my it didn't go out to public. Everybody's muted. Andrew, yes, sir.
Good evening. Is there any way to briefly describe how a DI connection to the oil fail to reset it remotely? Is that something that you could throw on the whiteboard real quick or no?
Oh, yeah. So it's basically the same thing as you just remove the oil fail control and wire nut L and M. Let me show you on the whiteboard here. You want to know how to do it or how it's working? Or both? I guess both. Swing my microphone over here. Okay. So the oil fail that's on the computer, you just delete this, cover it. That doesn't exist. Let's just pretend that doesn't exist. And that is wired over that. That's it. That doesn't exist.
Everything else exists. Okay, that doesn't exist. What it does is it takes the Centronics sensor, which, as you know, the Centronic sensor has that little O-ring in it, and that O-ring divides up here and here, sump and oil pressure. Okay. Let's just put it over here for right now into a DI board. So here is the Centronic little module. The threaded thing on there, and it's got the O-ring and little hole here. Whoops. Hole there. Hole here. It's got I believe it's oil. I don't actually know which one's which, to be honest with you. I don't know if it's the bottom one's oil pressure and the top one is sump pressure, but one is each, and it has two wires coming off. Those two wires, it's just a circuit that closes when it's got oil pressure or not. That goes to your DI board on an input, right? That just goes to an input on a DI board, or well, AI/DI. We'll call it AI/DI. So it's designed in software in the program. Emerson one is the easiest and works seemingly the best to me, as far as I'm concerned. The Danfoss one is weird because you have to add all this other stuff. Why can't they just say it's got it? I mean, it has that, but I guess it doesn't work right. I've never tried it. We've just always added all those other tasks, the miscellaneous tasks, and added it in there. But all it's doing, let's just say the RO calls for the compressor, turns it on. That's not there anymore. So it goes through the regular safeties. That could open at any time. And the contactor pulls in. This here is their oil pressure or not. Oil PSI with a question mark. If there is oil pressure, the controller will keep the RO closed. If there's not oil pressure and it doesn't get oil pressure for a certain amount of time, it just opens up the RO. It's that simple. It's much simpler than this. It just uses the two wires coming off of the Centronics. The Centronic is not, it doesn't have a pressure. It's not an analog input. It's a digital input. It's a closure. It's nothing more than a pressure switch. Like this low pressure and high pressure. It's just like this differential switch. The same way this differential switch allows electricity to flow. If the oil pressure goes up, it opens up. It doesn't allow electricity to flow anymore. There's no oil pressure. It's down, allows electricity to flow, opens that up. This is the same thing, except for all it is the DI is checking for resistance across there. It's an open circuit, and then it gets oil pressure. And if I'm not mistaken, it closes. But it'll work on either one. It doesn't matter. You just have to tell the controller, does it close with oil pressure or open with oil pressure? It makes no difference. The controller will do its thing. So it's all software. So all this stuff is based in software. You know, it closes, tells the compressor to run. If the compressor is not running or if it's running, there's no oil pressure, it's going to trip. So it's going to trip regardless. If the low pressure opens up, it's going to trip unless there's a CT built in. Now, mind you, on the E2s, and I believe, I don't know about the Danfoss, if it's got a CT built in, and that's another input, if the CT doesn't say the compressor is running, let's just say it calls for it to run. The CT says the compressor is not running and there's no oil pressure. It's not going to trip. So this is more software. This is just written in the program. But if the CT says, yeah, that compressor is running, the oil pressure differential says, yeah, but I've got no oil pressure. It's going to wait a certain amount of time, whatever's in the program, and it's going to open the RO and lock it out. It's going to latch it. And that's when you're going to see it's got the oil pressure alarm, and you have to clear the alarm, and then it'll reset and it'll try again. So if it does have a CT, a proof, a run proof of any kind, it's going to, let's just say it doesn't have the CT. If the high pressure trips, it's going to trip on oil. It doesn't know if the compressor is running or not. It just knows the RO is telling it to run. So trip breaker, coil open, whatever that, I don't remember what that was. Oh, overload, high pressure, low pressure, blown fuse, right here, blown fuse. All that will make the contactor not come on and have no oil pressure, and it'll trip on oil. So if you are tripped on oil and it does not have a CT, doesn't necessarily mean that it's got no oil pressure. Well, it does mean it's got no oil pressure. It doesn't mean the compressor was running. So just because it's tripped on oil does not necessarily mean it's an oil problem when it comes to the controller. I'd say unless there's a CT, but the CT could break. Anything could break. You got to remember, anything could not be working in the system. So, you go to reset it and the compressor doesn't turn on and it trips on oil and it has a CT. Well, now you've got a handful of issues you got to look into. You got to realize, why didn't the CT tell the controller that the compressor is not drawing any amps? That's first thing. But then again, also, that's just a secondary problem. Why did the controller for the contactor to come on and it didn't come on? Or why did maybe the contactor came on and it's a trip breaker? So why did the controller, it called for it to come on, the breaker was tripped, but why did the CT tell it was running? So it comes with its own issues. It is nice to be able to reset it easily like that. It's nice also that you don't have a lot of this other stuff in here. Personally, I'm old school, obviously. I like this other stuff built in. It really does away with a 3-wire old school oil fail control. Everything down here can trip, and it's not going to trip on oil fail. It's just not. Only thing that'll trip on oil fail is that, you got a trip breaker for the main. And everybody knows if you've got a trip breaker for the main on the compressor, you're almost always going to have a tripped oil fail. So that's how it works. It's just through software. And it's nothing more than that.
Okay, thanks, Mark.
Does that clear it up? You got any questions about that?
So the CT, if it has one, will control the RO?
No. The CT is just a proof. The CT is just giving it. Remember, we talked about EMS last time. These are just giving information to the controller. That's all it is. CT is just information. It's not controlling anything. Unless, in the case of a 4-wire, I digress. On a computer, the CT isn't controlling anything. It's giving information. That's it. The CT is a closure. It's an on-off switch. Basically, it'd be the same thing if you had a guy standing there with a gauge and it came on. Compressor it called for it to come on. It shows a light. It called for it to come on. And the guy is standing there looking with an amp probe and an oil pressure gauge. And the minute he sees The amp probe goes up, he flips a little switch. All right, sends that information. And then the oil pressure gauge goes up, flips the switch. All right, now it's got oil pressure. It's just giving the information to the computer to make its decisions on whatever it's been told to do. So it's a more high-tech way to do it. I mean, that's fine. It works fine. I honestly, I have very little good things to say about how Danfoss does it, but it works as well.
So resetting it remotely would and it works, that would be because of maybe a power outage or a brownout or a nothing's wrong, but there was an interruption somewhere.
Could be, yeah. Could be. There's a billion different circumstances, but it's got, especially if we reset it remotely, we can graph this stuff up. We can see it. I can see remotely. Did this close? Did this close? We can see those remotely, those closures happening. So we can look at that. We can pull graphs, which is nice. This is nice to pull up graphs. You can see what the controller is wanting to do. You can see the information that's fed back. And you could look at the graph and say, oh, shoot, look at here did this and this, and this did this and this. That doesn't make any sense. And you can do a lot of troubleshooting through remote with the oil pressure like that. It's a perfectly safe way to do it. It's perfectly fine. The only downside, I guess, would be where have I seen? I have seen some downsides on the oil pressure cutout where, well, I do know one thing though, that I have seen downsides on the Centronics wired 4-wire. That's a disaster. If somebody or if the CT goes bad and it stays open and that compressor, if it's wired 4-wire on a Centronic, the CT goes bad and it never powers up the 240 circuit, that compressor is running without oil control. So that's another reason I'm partial to a 3-wire, because what powers up the circuit is everything before it. It's safer, in my opinion. More safeties are built in to a 3-wire. You don't ever want to lose power to your circuit here in oil fail. There is a scenario where it's got no oil pressure and it still runs. Like I'm not sure on a lost board if that'll do it. If it shows lost on an AI/DI board, will that do it? I'm not sure. I haven't ran across that. It might. The E2s are pretty smart. It might say, hey, I got a lost board. I'm not going to chance it. I'm not going to run the compressor. So those are all scenarios you got to be running through your head. Like, okay, what's going on here? So that's why it's good to, I'm glad you asked that question, because, if these inputs aren't working properly, other stuff's not going to work properly. Obviously, if you don't have a CT and it's calling for the compressor and it's not running, it's going to trip it on oil fail, even though it's off on head pressure. So just because the controller says it's off on oil fail doesn't mean that's it and you walk out the door. Follow what I'm saying? You might push the oil, might clear the oil, reset, and say, all right, I'm out of here. Well, hold on there. That compressor may not be coming on. You got to make sure it's coming on. You got to make sure it's not tripping on high pressure. You got to make sure that it's not short cycling on the low pressure control. You got to make sure that there's not a loose wire at the contactor. There's a whole bunch of things that you're going to want to look at when the controller is doing it. But just so you know, it's nothing more than just a signal telling it whether you got oil pressure or not, whether the compressor's running or not. But I do like the ones that have the CT with the oil fail, the proof switch. It makes more sense. But you know, what makes a lot of sense also, I really like the oil fails on the scroll compressors. I like those. I like those a lot. They're just simple. They work. They've got safeties built in, and they're just looking at a level. The oil level's good. Keep her running. That's go ahead.
Can you graph it as good on a Danfoss as you can on the E2, or is there any difference?
No, graphs are the same.
Okay.
I can graph any input on the E2 and the same on a Danfoss. In fact, Danfoss, in my opinion, is a better looking graph. On my end, it's easier to see. It's also goes farther back. I can graph more points, and it just looks better. It's more pleasing to the eye, but it's the same thing. All you're going to be doing is graph up the inputs, graph up the outputs, pull the graphs in together onto a screen, and they can line up. Everything lines up, and you can see what's going on. You can graph the same things up in the field. If you want to troubleshoot, maybe one day we'll do that. Maybe next week we can get to that where I can show you how to graph things up properly. I mean, I know a lot of you guys call me, and I pull up some graphs. And I can pretty much see it tells a picture. It tells a story. It's like a picture that it shows what's going on. And you could do that too. You could pull up graphs in the field. So, but yeah, graphs will tell you everything. That's another reason why this is good. The oil pressure in the controller is a good thing because we can graph it up. We can see, especially like, shoot, Dan, you got like a sensor on a suction header, and then you graph up the sensor for the suction header and the oil pressure, the CT, and you can see the suction pressure goes down, it's flooding, and the oil pressure comes and goes, it flitters. It's like, holy crap, that thing's flooding back. And you can see it. It's like literally draws you a picture of the rack flooding. I guess it really, if you can read them, reading the graphs is part of this, half the battle. Yeah, I like him on the controller. A funny story is we did one store, and so when you take this out, you take the controller off, you have to have a pull box to put all these wires in, right? You cap off this wire, and then you wire nut the L and M together, but you have to put it somewhere. So we put in a handy box, right where that controller used to be. Put in a little 2x4 box, handy. They call it a handy box. So I think it was Brandon. We were joking around like, let's put a blank cover on there, but make it look like a Centronic, and then put it like a drawing of a button. So the manager goes in there, he's like, oh, keep resetting, and it calls you up. I keep resetting it, but nothing's happening. There's nothing but a cover with a picture of a reset. I don't know if we ever did that, but I thought that was hilarious.
Okay, very good. Thank you.
Yeah, that'd be a really good class. Reading graphs. I want to put that on the agenda. You guys want a class of reading graphs? I think we've done it before when we had an emergency before and pulled up a graph, but I was really going quickly. So I don't know if everybody got to see what I was doing. Because as you're working quickly, trying to data without explaining it, it's not very helpful, I imagine.
Graphs are like charts,
They are, but I was reading them so quickly when I was doing it, those emergency times, that I didn't get a chance to explain what I was doing. But yeah, I think that'd be a good class. Graph reading 101. Let's do it. All right, so it is time for the spin. We've been an hour and a half. Appreciate everybody coming on here. We are going to end the YouTube stream here. If anybody wants a link to it, I have been recording them every week that we're doing this. If you guys want to start doing it weekly, we can start doing that again. Yeah, Mikey? Mikey, you're muted. Mikey, can you hear me? All right, everybody in YouTube land. Are you good, Mikey? All right. So everybody in YouTube land, we're going to end the stream here. Stand by. It takes about 20 seconds. You'd like to do a TikTok? All right, stream is